Hi, I'm Jeff Lawton, and we're going to take you on an earthworking adventure to a student's property of mine. EJ did a course with us about 4 years ago, and we're going down to help him design his property for a water harvesting event. We're going to have an earth mover there, and we're going to build a dam, swales and a few other features. And some of my most recent students are going to be with us for the experience, and it should be a lot of fun. So come along with us, let's go and see what happens. EJ Merrick lives on a small acreage just outside the town of Woolgoolga in northern New South Wales. This is his house and the boundary of his property, which is about 6 acres, and it's in amongst regrowth forest, and it borders a small creek that runs through the edge of the forest and through the forest itself.
We've got half a dozen acres here. It's a little patch of rainforest down on the creek. Woolgoolga Creek borders is one of our borders or boundaries, and it's a piece of land that I looked at it probably 10-15 years ago and thought, wow, how do you ever, I'd love to live here. And we got the opportunity back in around 2001. And it's half a dozen acres, and we've really sort of set some basic guidelines in what we want to do and how to preserve it, and especially the rainforest factor. Water's always been our situation, is to have enough water to be able to water your plants on a consistent basis. Even though we've got the creek down there, I've never felt comfortable in taxing its waters to grow or to maintain the property. I mean, we have our own veggie patches and try and sustain ourselves as much that way. So we've got about 50,000 litres in water tanks there at the moment, and then we do have the creek to pump up from for household use.
EJ's property is located on the side slope of a ridge, and he's emailed me and sent us a topographical map of the area and marked out roughly the spot where he thinks the dam should be located.
We've always wanted to put it in a dam. We've got a dam site down the bottom of our main paddock, I suppose you'd call it, and because then it borders onto the creek, it will be within probably 30 metres, I suppose, of the creek itself. I've just always wanted to make sure that what I was going to do do correctly. Okay, I pretty well pegged out the area that I thought, where I believe where the dam should be. I think that's the best location on the farm. I know that we have to lose a few trees, a couple of gums, mainly so that they don't sort of come back into the dam wall and make that less strong. I'd like to see it. I'd like to see it with a food forest that you just go, wow, that's really just taken off, because we can grow most things here on the North Coast, and I think we deserve to have a really good food forest, small crop, enough so that A, from a family, but B, for all surplus to be used in the local area, and just like the permaculture ethics, I suppose.
It was the afternoon when we arrived with a group of students to start the whole exercise.
I thought the inoculant fantastic.
Beautiful. 2 million bacteria. Yeah. We brought down some root inoculant for the cover crop. We're going to put cowpea in as a cover crop to repair the earthworks, and this is millions of little root nodule bacteria that we're going to inoculate the seed with, so that it fixes nitrogen really well and does a quick repair job and improves the soil after we've pushed it all around. Well, I don't know where we are. I don't know. I don't know the land at all.
Yep.
I've only seen it on Google Earth. What is it? 15 acres?
6.
6 acres.
Yeah.
All right.
Yeah.
And it looks pretty forested.
It is. Yeah. And we've got some space down the where I'm looking at is just down the bottom of this main paddock here.
All right.
And using the hard stand here, the road is probably one of the major sources of the water.
All right. This is going to be the water catch.
Yeah. We get
right.
a lot of water runoff.
Yeah.
When it rains big time, straight down the hill.
All right. So we should be able to see that.
Yes. Yeah. You can see it where it's.
Yeah. Well, I was pleased to see there was quite a good dam next door.
Yes, the next door over here. Yeah.
That holds water okay.
Yes, it does. Yeah.
All right.
Yeah, and it's been there for quite a few years. Yeah.
All right. Good. Well, that's encouraging.
Uh,
And then we'll set up camp, and then we'll go for a look around and peg some levels and have a look at a few things, eh?
Beautiful.
AJ, when you asked Jeff for the consultancy, can you just tell us what information you needed to supply him with?
Jeff was after topographical maps, so the contour of the land. I also sent him some pretty reasonably detailed photos of where I planned to put the dam. Also pegged it out as well as I thought where it should sit. Also, then we just had which is technology, the Google Earth of download. So for the location of where it's at. But mainly just the lie of the land was where it was. That was what he wanted to see, and the surrounds.
Water's central to design. So when you come into design, where there's water, there's life. Where there's water, there's extra potential for fertility. Water's a main element that everybody needs. So you're really you're always designing water as a sort of forefront of design. You're coming in and sort of looking at the way to direct water, soak water, impound water, create drinking water, irrigation water, water for stock, water for growing systems. And it's just accentuated in the really dry areas. But it doesn't really make any difference. Everything's a comparison with what you've got. So if it's drier than it normally is or wetter than it normally is, that's a comparison in relation to the surrounding landscape. So if you can modify that, if you can make it less erratic, if you can make less floods and droughts, if you can moderate water to be productive because it is less erratic, then you immediately start to get a good result in comparison to the surrounding landscape and scenario. Let's have a look first, and then we'll actually do a bit of pegging. Yeah. So this is the dam site generally.
This is what I was thinking. Yeah.
All right. So that's the sort of body of water you're looking at.
Oh, pretty well.
So how far that way do you go?
To past this little stand of trees, you see a little bit of scrub just behind that. So probably 5 metres plus behind this little stand, not this first tree here. Your next 2 cheese trees just behind that.
Those 3 cheese trees stood on their own?
Just here.
Yeah.
Yep. And then from this last log,
Yeah.
7-8 metres.
Okay. All right. And then this way?
And then this way we go across the bottom. We've got about 100 metres right across. So we've got pretty well half on this side and then half on the other side.
So the water, obviously these trees are going to get in the way, so they're coming out.
That's correct.
Yeah. And this is where a lot of the water flows down this bit here?
This is, yeah.
See how far off on those pegs, or where you are on those pegs. I'm just looking at the height of the wall, where the height of the wall would be.
Mm-hmm.
So the bottom of that peg over there roughly lines up with the fork in this tree.
No, just here. This one. Yep.
Yeah. So the bottom of that peg lines up with about right there. So by the time we come out here, we're going to be up there with a wall. Yeah. No, probably a little bit more. So that'll be curving round. The highest part of the wall will be back here. Down a fraction. Down a little bit. Down a little bit. Yeah, that's waterline. 75 mil above that. 750 mil. Sorry,
Okay,
3/4 of a metre. Just as a guesstimate.
Yep.
Just depends how big a dam you want. But
Well, I thought if we could get in and around the 300 to 400,000 litres.
so we could squeeze it back as tight as we can on those trees, so the batter goes as close to that. You don't want to disturb that.
No.
No, leave all that.
Yeah.
So take the batter down on the back. You know, take the back slope of the wall down as close to those trees as possible.
Yes.
And then pull into this. It's really a contour dam. Contour dams are built on the side of a hill slope, and it's important that you take levels for the waterline you propose to achieve and build the dam with the material excavated from the impoundment to achieve a wall height that's higher than the proposed waterline, so you have a secure dam at the finish of the job. And you didn't over that way, we can just pull in a little bit of a wing. We can go to the boundary with a wing through there if you like. It's not really a swale, could be a swale.
Yeah.
And it will just come in at that height up there. It will come in at the top.
Yep.
It won't come in on the wall because the wall's high. It'll come in up there. We're proposing that the dam has an extension of the dam wall to a level sill spillway swale that will overflow any excess water very gently through the forest back to the creek. No chance of any erosion at all. This is feasible, picking up from there. That's feasible probably without any too much problem to run a little wing out there like a swale, but like you could run a wing that way. If you think it's, you know, if it doesn't get in your way.
Well, I don't think it will. I suppose the only other thing, like I hadn't really thought about that, but then maybe we were talking before maybe about with a swale that's going to come across through the next paddock.
And we could put other swales up there, but they're inside the catchment that you've got.
Yep.
We'll have a look in a minute to see if there's anything extra, but it doesn't look like it. It looks like there's no, you know, with your that's your boundary fence there, isn't it?
Just behind the tent, yeah.
So you've got everything this side of the boundary fence. There's nothing you can do on this side of it that really increases catchment that side. But this side looks like it goes for miles. This goes a long way. So when you look uphill from here, it's all the runoff from the tanks get included. They come this way?
Oh, just on the other side of the green fence are the tanks.
Right.
So everything falls back down over to there because it drops off again and then heads back down.
It drops that way?
Yeah.
But could the overflow from the tanks come this way?
Yeah.
Wouldn't be that complicated a bit of plumbing?
No. Well, actually, you can see the tops of the tanks through here, just ever so.
All right. From what I can see, we're more or less on a ridge mostly in a forest. Right. So we're on a sort of, you wouldn't call it a sharp ridge. It's quite a rounded ridge in a forest. There's quite a significant valley at the end of the ridge.
That's correct.
Yeah.
It's straight down. Once it drops down, it's quite pronounced.
So we're on this ridge, and the house is really on the crown of the ridge. And what we've got around us is 50-year-old regrowth, 40 to 50-year-old regrowth probably.
Yep.
In this climate, I mean, a lot of it's actually 20 to 30-year regrowth, but there's some 50-year-old trees in amongst it. That's all, I would imagine.
Yeah, on this side, but just speaking to the neighbour there before, and another mate here was talking around 30
years. Yeah, it would have been all cleared.
Yeah, it was once. The whole section, sort of almost back to the highway, was dairy.
Yeah, that'd be right. It would have been all dairy before the common market happened. So we're just looking at big eucalypts poking out of what probably was a rainforest once.
Yeah.
And we've got a garden setting. and a possibility of, when we've only got a road to capture in runoff, hard runoff, that'll be good because it's flash runoff. And they've got a possibility of pulling in extra runoff from the house, hardware, roof, tanks, garden. And it's just a matter of pegging it now to see how subtle we can get through with levels, because that's the one dam site of any size.
Over here. Yeah.
But until we peg through from there, if we just, it won't take, we've got a few of us to peg and everybody's learnt how to survey.
Yep.
If we peg through, and it's possible to get a sight through that bit of bush into the next paddock, it would be ironic if this swale lined up with that other little dam potential.
On this side over here.
Yeah. So if the two were sort of wishbone together, right.
Well, it could work.
But we won't know until we actually just do some pegging.
Yep.
And then there might be a scenario where you might want to just sort of clear a little bit of a corridor through, get a swale through. It won't take much. The most work will be in the dam.
Yep.
Be all the compaction. What size machine is it?
15 tonne.
15. Right.
Is it going to be too big? Like, I mean, not once the work's done, but I mean as far as this.
No, that's almost ideal for the swale.
Okay.
Potentially a little bit small on the dam.
Yeah.
But if he knows the country, it'll be all right. I'm just looking at all the possibilities. So when I go in on a design, I look at what the client wants as far as where they want dams, and I look at where we can actually pull more and more and more water towards that dam, so it's always got an extra overcharge of water. We're not going to be short of water. It's this dam's not in a valley, it's a contour dam really on the side of a very small gully beginning, so it's really just on the side of the hill, and all the water just comes running off a road. So this extra bit will make it a lot more creative. And then I'm just exploring the possibility of taking that as far as possible, and it's a little bit different because you're going to be squeezing it in between mature trees. So it's not like you're in an open paddock where everything's damaged in every direction with totally cleared landscape. You've got a sort of older garden tree system and a small acreage to get round.
That might be difficult.
It might be difficult, but there again we won't know until we do a bit of surveying.
Okay.
We do a bit of simple surveying and we'll quickly work it out. We'll be surprised, I expect, where it goes. Because it's never exactly where you think it's going to go. So we've got a laser level with a little bubble. So it's a little spirit level bubble. Sets it up. And then when we get a starting point, we can start it off if you like. Let's check these two pegs, see how far off they are. Finding an accurate waterline level using a laser or a dumpy level is a matter of surveying off a staff height that relates to the height of the measuring instrument. Where the staff touches the ground and the laser receiver beeps, that's the point of your waterline marker peg. You can walk around the landscape. Every time you cross the beam at the right distance, you can put in another peg, and on you go, surveying your levels for your earthworks. We're just setting the laser so that it's at a height where the receiver can pick it up. And this is a little laser receiver that picks up the laser beam off the tripod. And then from here, once we've set an exact mark, you on? Where are we? That's level. Screw the receiver up tight. We know that's level. And we can check this other peg. That's level there.
At what point? Is it just here, is it?
No, right there.
Oh, there.
There is the same as the bottom of that peg there. Because I've got a signal there.
So
Just
the
stick that
base
one
of
in.
that white.
Right at the base there, where that touches the ground, is the same as where that one touches the ground.
Oh, I got you.
And that's what we're proposing. That's waterline, yeah? Okay. So this one, you were just a fraction high on this one. We can pull that one out. And we can peg our way this way and see where we get to. And we could set the other level up if you like. If you guys want to set the site level up, we could do 2 levels at the same time. So everyone, who wants to do this one? Want to do this one, Dave? You're going to be on film.
I'll better get it right now.
Yeah. Just walk off, say 5 paces. We'll do everything really close. You've got a lot of pegs, have you?
Yeah, well,
That's funny.
me and I can
You
get
want
a
that?
bit more.
And when you're just below the beam, it'll go dit 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 dit, means, and it'll have an arrow pointing up. And when you're just above it, it'll go dit 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 dit,
Going
dit,
up.
and that means go down. And then it'll have a little arrow
If you're
going down.
nowhere near it, it doesn't make a noise.
No, you've got to be within a few there.
Up.
Okay, hang on.
But the thing is, they're great, but if you want to look from one side of the valley to the other, you can't look through it.
No.
It's wonderful
You don't
because it's
know
a
where
one-man
you're going.
operation, a laser. You only need the laser set up, and that's doing it all by itself over there.
Oh my God.
And you just walk around with the staff and the indicator, so it's a one-man operation. But for teaching students about looking across landscape, the machine that's coming down now, which is what we call a dumpy level in Australia, or what in America they call a transit level, is a little telescope, quite a good telescope that you look out through. That's a 2-man operation. But if you want to look across landscape as a consultant, it allows you to look through it. So you've got a visual. You yourself are looking. Where with the laser, you're not looking, you're walking around with an indicator. So it's a little bit different.
How do you set where that is?
How did you determine that position over there?
All we did was make sure it was within staff height, so the indicator could go on the staff, of the starting peg. And our client, EJ, has said that's the waterline he'd like. So we already had a starting point, was that furthest peg there. So we made sure that the laser tripod was within staff height of that peg. And then we could set that indicator you can hear going off in the background. I'm just setting in level with the little bubble and the ring here. So that's sitting right in the middle, the bubble sitting in the middle of the ring. Like that. So that when you turn it around, the bubble and the ring should just there. Yeah. So that when you've got that set, the bubble always returns to the middle of the ring, no matter where you put it, and then you know you're seeing level around.
What do you see through the eyepiece? Is it just a crosshair?
Yeah, it's a crosshair and a very good telescope. That's it's got a long focal length, so you can focus it really close and focus it right out to infinity. Now you've got to come the other side. I'm down short. Yeah, come that side of it. Because I've taken a reading, just like the laser. So I've sighted through on a crosshair and taken a reading on the staff. So where the staff hits the ground, I can now judge. Come towards me. Come downhill. Keep coming. 100 mil. Keep coming. 80 mil. Hold on. Where are you there? Oh. Under a branch. Okay, go back a bit. Back a bit more. Uphill. A little bit more. Come downhill again. Yeah, it's right there. If I line it up anywhere on that same number where that staff hits the ground is exactly the same level as that starting peg hitting the ground. So I'm finding the exact contour through the landscape, and then I can see where we go as far as picking up water, because I can't move. You never move water uphill for free. But the best option for the longest distance and the most catch is to hold it on contour and drop it into the dam. And then I have the added possibility of back flooding the swale as a growing system. So we'll just see how we sneak through this landscape now. All right, okay. We're right here. Yeah, okay. A swale is a water harvesting ditch on contour with a soft contour mound on the lower side. It interrupts the water flow as it comes across the landscape and stops it on contour perfectly level, and the soft mound on the lower side soaks the water into the landscape and it plumes it through the landscape as a sponge very, very slowly. This is the essence of creating swales that harvest water in the most passive way and hold the water up for as long as possible, as high as possible, and create the most potential for productivity. The water that plumes down the hill from swale soakage continues to move at right angle to contour very slowly through the landscape. As you set more and more of these systems up, it's inevitable that eventually some of this water hits impervious layers that are almost horizontal, and where they meet the surface of the landscape profile, accumulated water starts to spring out in the middle to lower slopes. This is a way we actually recreate or invent completely new spring lines in the landscape, and that's another set of advantage that we can put swales to use for all sorts of extra water flows and productivity. So we're just on the other side of the fence from where the last level finished, slightly uphill, just below the house water tanks. There's a possibility of picking up this extra catchment from this way, straight down, well, round on contour, and then into the next swale and round to the dam. But how far this way do we go?
Virtually this line here. this line here takes us back to the road. That's the boundary. Yeah. So yeah, virtually back through this way.
We haven't got a lot of distance here, right? And it's just a matter of working out whether it's worth picking up that extra bit of water for the extra effort here.
So where's the water coming from here?
It's coming off this paddock, but majorly it will be coming off the overflow from these tanks, because this is an area that at times gets big rains, and there's a lot more water coming into these tanks than you can actually pick up and hold. You can pick it up, but you can't hold it, so they're going to be overflowing, and at the moment they're overflowing right here, and there's other bits of hardware here that the other swale won't pick up, but this will. So it's a matter of working out, is it worth putting the extra little bit of effort in to pick this water up? And the answer normally is yes. It's always worth going a little bit more, as long as it's not extreme. It's not that it's a lot of work, it's just a little bit awkward getting around the trees. I've just noticed that looks like that's the septic trench just here. It's probably the runoff from the septic, which would be quite interesting, because that's an extra sort of nutrient going through. The main thing would be the area from the roof going through the tanks. If we can pick those up, that's a lot more water going towards the dam. what we wanted was the back of the wall just to touch into the edge of the forest.
Okay. Yep.
And then we've marked right across here the peg on the other side of the big log.
Yeah.
We're going to run a little swale across there too, once we get the height, and then just run a level sill spillway off that end.
How steep's the back of your wall, though?
Need a freeboard above that. We just looked at actually where the dam's going to fit in the landscape and how he sees that, and he's quite confident that that's okay. And we talked about the type of soil we've got, so the clay content he thinks is really good. So we just discussed with the client exactly which trees are coming out the way to build the dam, and the operator seems to understand exactly what I mean by a contour swale, on what that sort of earthworks looks like and how we build it. So we're just we're ready to go ahead and get the site prepared. That's the main thing. Even at the early stage, I need to find out exactly what's underneath the ground. Yeah, just looking at the material, we've got a bit of shine there. So it looks like there's quite a good clay content in the soil. And it starts to stick together. So it's the first time we've gone down in the ground a little bit, and already I'm quite optimistic. It's like good stuff. As we go down, there'll be more clay, I think. That polish, that shine from the machine's pressure, is always an indication straight away there's some clay in there. It's got an actual, where it's compacted by the machine's pressure, it's already sort of shiny and clay-like. So that's the sort of thing we're looking for. So the deeper he goes at the start of the job, the more I'll be following him into the hole to actually have a look and see what the clay contents are like and see what materials we've got to work with. You've got a pretty good idea, and the local people who drive the machines, they usually know quite well, but you can be surprised. There can always be something odd under the ground. So you're keen to see what's down there, so you can make a judgment on the job. You can say, right, okay, let's keep going, or let's just be cautious, or maybe let's stop and have a look a minute. Let's just stop working and reassess. Yeah, so we've cleared and prepared the site. And the first thing we need to do now is to strip off the topsoil and stockpile it, because we're going to use it later to go over the clay wall surface so it can be revegetated and nicely greened up. The topsoil is too valuable to put underwater or to mix with the subsoil, because it's taken hundreds of years to create the topsoil. So we're going to carefully skin it off, and we're going to put it either side of the wall on the lower slope, so that it's nice and convenient to put back over the dam wall when we finish the construction. And that's a process we do every time. We don't waste topsoil, it's too valuable. What we're going to do is we're going to resurvey the water line, so that the driver the operator of the machine can see quite clearly where the water levels are set, and that gives him a lot more confidence that we've surveyed the perimeter of the earthworks, and he'll drive a lot faster. Now the topsoil is removed, there's something really strange here I need to have a good look at. Got the fire here, and we've got a clay there. There are certain areas that you'll find on any site where there has been fire, they'll get terracotta instead of clay, and it took a while for me to pick that up, but doing earthworks here and there, you see it quite often now. Now I know what I'm looking for. I can almost see some fire effect on every site. In Australia especially, where they've been cleared, if this was a dairy 35 years ago, probably 100 years ago it was forest, and then they would have cleared it in a quite brutal way, hand cleared it, and to get rid of a lot of the material, they made big piles of timber and burned it off. And of course now in permaculture design we try not to do that. We might cut it up little bits for firewood or log firewood, but we tend to mulch the rest of it, like we're going to do here with wood chipper, and turn it back into mulch. actually turn it into good soil. There's a couple of spots right here where you can see dots of it. Yeah. That's the clay cooked. And of course, if you wet it up, it won't become clay again. It just becomes like broken terracotta. If there was a big fire over this one area and it was a lot of logs were burnt all in one spot, yeah, you've got to be careful. It won't necessarily seal anymore, and so you've got to look for that as a possible problem. But little bits like this won't matter. It's just interesting to see the history burnt into the geology of the landscape. Just there. It's about as deep as it goes. Just see that it's deeper here than it is at the extremities of where the dam wall's going. So that's an indication that water has gathered a little bit more down the centre here and built this extra topsoil. This is the spot that most of the water dragged down the nutrient and the mulch and the organic matter. So now with a few scrapes and we're ready. The whole site's prepared to actually start digging in the keyway that locks off the water underneath the dam wall. So the dam wall will be actually locked in with a foundation of clay, and that's something most people don't understand. That's positioned underneath dam walls. It's very important to get the keyway well constructed under the dam wall, so it locks the dam wall into the landscape and stops the water going under the dam wall. That's the foundation underneath the dam wall. So what comes out of there get put on the back, and then some really good clay will come out and fill that and get track rolled in as the foundation of the dam wall. That stops the dam leaking. That's one of the most important parts of the whole dam. So it's like the foundation sealer that locks it into the hill. And now we're going to go down, so we're going to see what's under us.
How deep do you think down will you go?
I'm probably going to go 1.5 metre and a half. I don't think we've got a problem here. Everything looks good. Maybe 2 metres. Well, now's the moment of truth when we actually start going under to see if there's anything unexpected underneath the ground. And it's all what we want, rather than seeing rock or shale or gravel or sand or any of the things that won't seal. Yeah, so we've got the keyway going in, and it all looks good because the clay is really nice under the ground, good solid material, and we're cutting it in the shape of a V because it's only a small dam, not with a huge catchment. It's not like it's got the pressure of a valley catchment on it, and it makes it easier for us to track roll it in with this particular machine. So we've got a V-shaped keyway. So it's a keyway like an engineer's shaft, where a key fits into a slot in a shaft and locks the shaft. In this case, it's a giant keyway underneath the dam wall that locks the dam into the hill on the sides and the bottom, and actually stops the dam leaking under the wall, so the water doesn't find its way under the main compacted wall. And everything looks good so far. And I don't think we're going to have any problem with material by the look of this. After this, we'll fill this with the best clay we can find in the hole where the water's going to sit. And we'll pack this in, and then we'll start building. Then we'll start actually getting a bit of height where we compact the dam wall up into the air. But at the moment, it looks like we're going in the wrong direction. Where we should be building a wall, we're digging a trench. But that's okay, because this is very important we get this bit right. Well, we've got good material straight away come out of the keyway, and that's gone onto the back of the wall, and we're starting the long process of track rolling. So we're already track rolling the material in, and that's compacting the clay so it becomes tighter and more compact than the original material that was in the ground. And this is how the dam wall's sealed. So from now on, all the way up, we'll be spending a lot of time track rolling. We'll dig for a while, spread the material into the rough form of the wall shape, and then we'll track roll and track roll and track roll. Most of the process in time is about compaction and getting good quality compaction so that the wall doesn't leak. And this is the beginning of it, and it's all looking good so far. One of the questions I'll always ask a dam builder is, or an earth mover, do you always bother to put a keyway in? And if they emphatically says yes, I wouldn't do it any other way, then they're the sort of operator I want to work with. If they say, oh, maybe not always, I'm not sure that I want to work with them, because it's most important you do this bit. This is what makes a dam fail. This is one of the things that makes a dam fail, not doing this bit quite right. So that's what's building dam walls is all about compaction, and that's what takes the time, and that's where most of the work and effort is put into compacting the wall. When we get to building the swales, they're not compacted, they're all about accurate levelling. That's a different sort of emphasis. People are more and more interested in this type of work. As water becomes a major issue worldwide, many students, design students, who are really interested in how to design ecology, how to design environments, they want to know how to design water into landscape and how we design water harvesting and water impoundments. So we've got a great interest in how do you actually do this sort of work? What is the mechanics of it, and what is the stages and process, and that's what we're trying to cover here, so we can make something that's very informative, that people can realise, oh, with a little bit of extra study I can understand exactly how to do this. The operator there just touched a peg, and he's going to straighten it back up. That's how accurate these machines are. He didn't like that. He actually touched a peg, so he straightened it back up, and he's going to make sure he doesn't touch another one. They're as accurate as accurate as a human hand, really. It's like a giant hand. It's a very creative machine, an excavator like this with a tilt bucket. And ideal machine for this type of work, where we're doing a small dam that needs to be very attractive looking and aesthetic. And a benefit to this property, every dollar spent here will be quadrupled in the value of the property increase with this actual earthworks. So whatever we spend here, we'll put 4 times that amount on the value of the property very quickly by putting in this sort of small dam feature to this landscape. Well, we're nearly at the end of the first day, and we're about halfway through the excavation. The clay just keeps getting better as we go down. We're going into a sort of grey clay now that's even more solid than the red clay, and we're starting to build the wall up and compact it off, and everything's going really well. And I think we've got enough material in the hole to build the wall, which is something you're always concerned about. Are you going to have enough material? And in some situations of dam building, you can have too much material. It all costs money to move, or energy to move. But everything's going well, and the customer's happy, we're happy, and we think we're going to get the job finished tomorrow. So we'll be back on the job at 7 o'clock in the morning. Well, day 3 from when we first started surveying the site, and everything's going to plan. We've got better clay as we go deeper. We're getting this sort of pink coloured clay that's almost 100%. The wall's going up, and we're going to make fast progress now. So beginning of the 3rd day, everything's looking quite optimistic that we're going to come up to finish in time. The wall has to get above the ground where these pegs in the foreground are sitting. So that's our target. We want the wall to get actually 3/4 of a metre higher than the pegged shoreline that's just in front of us. And we think it's all looking good. The dam actually is going to start to look bigger and bigger as we taper the wall back. We've just done our level calculations. We've surveyed across the dam from the waterline pegs over to the dam wall, and from waterline plus 750 mil, which will be the water that'll be the dam wall height that'll stand above water, what's called the freeboard. We've put a marker on the tree over here to see what our target height is, and that's where we're aiming for. That's how much extra wall we have to build, and the wall gets a little bit narrower as it tapers towards the top, but it'll still be about 3 meters wide at the very top. So we're looking good with the materials, so we're pretty happy, and we've got our calculations and measurements all done. Here we are with our soil test, and the clay has now settled. It's almost clear water at the top, and right at the bottom there's a tiny proportion of sand. It's more than 95% clay, so that makes us feel really confident that we've got a dam that's going to be very well sealed.
Day 3.
Day 3. Fantastic.
Tell us what's happened and how you're feeling about the whole progress.
Yeah, well, look, this is the second day of the excavator being here, and he's just really starting to take shape in the dam. Removal, the site preparation, I suppose, like any preparation, just takes the time that you're really not expecting, so to speak. It takes longer, but we're really fortunate enough. We're really good clay, and feeling just like $1 million. This is it's happening, and it's beyond happening. It's the reality is taking place in front of my eyes. Really, really good.
This is one of the second most important point in dam building is the spillway, and in this case it's linked to a soakage swale, and it's a little bit complicated, but it's very simplistic at the same time. The swale's level and it catches water to the dam. When the dam's full, it back floods up the swale, and there's a level sill spillway we've surveyed that is 100 millimeters higher than the bottom of the swale. So a level sill is a very accurate edge that displaces the water over that level surface. Now, whenever you put water on contour and whenever you take it over a level surface, you pacify water. So if you've got a lot of water discharge over a level sill, you make it a long level sill. This isn't going to have an enormous amount of water going over it, so we've made a level sill about 2 meters long. Right? And that's what we've been surveying now.
We might have to do that before we all pile into it.
Here's our level sill. That's perfectly level, and it's 100 millimeters higher than the water line. That's the width of our level sill. And this tapers down to the back of the swale. And the level sill itself tapers down to the inside of the mound. And the mound is here tapering up to there. So this is one line, and that's the back cut. So your water will sit in this swale at full height and rise up 100 mil, and when it gets to 100 mil it will go over that level sill there, because the mound of dirt that we've excavated is sitting here and it's tapering back to that point there. So the mound itself will finish about here, come around like that. This will be a mound of dirt, and that'll be an excavation. It's a little bit of measuring to do, a little bit of mathematics, but it's not rocket science. And once you've seen the earth mover actually pull the dirt and move the position, move the landscape around a bit, you see it's quite understandable. It's just the first time that you take people through this exercise. It can be sound a little more complicated than it really is. And even more simplistic, once you see the actual dam working and the overflow actually displacing water, you see how passive it is, and you realise there's no chance that we could ever cause any erosion doing this. It's about the most passive thing you can do with water, and one of the most productive things is to soak water very slowly through the landscape, and if you have to discharge it over something that's very level.
Okay. Where are we up to at the moment?
We've just run out of material.
Say that again.
We've just run out of material, more or less. We're on the last little bit of material. So we're going to take a little bit out the bottom, and then we're going to see how far, how high we get.
So all the swales have to be recalibrated or measured?
Yeah, we'll have to remeasure them. We're not quite getting the height.
Oh, you got there, so
it'll be that. So the whole thing will be moving down.
Well, that'll be pretty...
We're pretty much as steep as we can go on the back cut, and we can take a little bit out of the inside of the wall, and then we've run out of sort of material to cut in clay. Then we're going to put the topsoil back on, and that'll get us another sort of 150 mil on the wall, and then we'll have to take measurements from there.
Is this the sort of thing that happens pretty often?
Yeah, quite often you get to a point where you just haven't quite got enough material, or you're chasing material on half the jobs, and the other half of the jobs you've got too much material, and both are awkward. Well, we're at a point where we're realising that there's only so much material in the hole, and we may not quite reach the wall height that we thought. So in which case we'll have to re-survey our swale lines. But we can definitely get up to waterline height, but that's not good enough. We've got to have enough wall sticking out above the water to handle a surge if it happens in a big rain event. The wall that sticks out of the water is called the freeboard. It's the same name as used in boating and shipping terminology for the hull of a boat above the water, freeboard. So there needs to be enough freeboard in the dam wall to handle a very large surge of rain during a major rain event. On a lot of farm dams we keep it to a metre, and even more on big dams. On a small dam like this, 75 centimetres would be okay, 3/4 of a metre, maybe half a metre. The danger is if the water starts to go over the dam wall for 20 minutes, half an hour, it'll cut the topsoil off the dam wall, it'll cause friction, it'll start to cut a channel. That channel will exaggerate the erosion because it's all carrying material with lots of friction. And if that rain event continues, it can pull the whole dam wall down. Now, it won't come down in a big crash, but it will come down as a rapidly eroding canyon, starting at the lowest point of the wall and then cutting through. You might think, well, you rebuild the wall, but the wall has to be built out of clay, and there's only so much clay in the hole, and we've just used it all. So if it ends up going down the hill a long way, or into the forest, in this case below us, you can't get that clay back. So now you have a big hole that won't hold water because it hasn't got a proper wall in front of it. And the only thing you could do then is buy clay and bring it in, and that's an expensive exercise. This is not an issue with a swale wall. A swale water harvesting ditch on contour with a soft topsoil mound on the lower side is not compacted, so if ever they go over the top, there's a very small amount of erosion. It's a very soft wall. It's something you can mend with a shovel. You have other topsoil around you can mend it with as well, but you only have so much clay in an excavation. So we're having a look at these levels and make sure we get all this right, and it may mean resurveying around a new potential wall height.
You weren't originally thinking about swales, were you?
Well, yeah, not really. Like, I knew we were going to get that swales was on the agenda. Where it went and where it's going to go just makes infinite sense, because we're going to pick up the whole farm.
Here we are on the driveway, which at the moment is the only main catchment for the dam we're building. And the driveway's compacted and it's hard. Although it's gravel, it's still hardware, and the water's not accurately directed. It's actually vaguely directed off to one side, and what we intend to do is grade the driveway over so that it tilts into the inside of the bend, and then right the way through hold that water in control and let it go just at the end of the carport there, so that it directs down the slope through the fruit trees and into the dam. So that way we're going to get all the water from this driveway. Now the thing about driveways is, and all hard surfaces, is when there's a small rain, they get 100% runoff. So you get directed accumulated rainfall off the hardware to your catchment, to your dam. The landscape doesn't do that. When you have light rain, particularly after a dry period, it all soaks in and none of it runs across the landscape. But hardware runs because it's non-pervious. It's impervious, shall I say. So they're great collecting services to actually soak water into the landscape in specific places and store water in impoundments like the dam we're building. And that's what we'll do. We'll concentrate that water by design. Now, because we thought we were going higher, the back cut is above waterline, and that doesn't look nice when the dam's finished. So we're getting the driver to cut a ledge along the back of the dam, which is just 100 mil below water, and we're going to backfill it with some of our spare topsoil. So there'll be a beautiful fertile deep topsoil ledge behind the dam. That means the dam can be nicely revegetated and it'll end up with much clearer water. Otherwise you're going to end up with a clay bank, and that doesn't look good. Now, because it's all suddenly, as usual, we're doing nothing for hours, and then all of a sudden we've got to do a load of things. Now it won't be long before we're ready to put the swale in. That has also got the spillway at the other end, and we were having to reset all the levels. So for the students on the job site, it's a great exercise because this is reality. We're actually doing this, and there's a machine running here that's 15 tons, right? And it's costing money per hour. So they're here to get this exercise, and it is a real exercise. They're now surveying and doing their checking of levels so that we can run this little swale out at the new height that harmonises with our new water height. And this is typical sort of dam building exercise. You don't always know whether you're going to make it to a height, and if you do, you've got to change the whole plan. It doesn't mean it changes the pattern's the same. The pattern is harmonising with the contours in the landscape, but the levels have changed. So now we're re-levelling it all, and it's quite good fun if you don't get in a panic.
It's a bit of adrenaline.
It's a bit of a rush. You've got to do it. You've got to do it, and you've got to get it right, and you've got to get it done quick because there's a machine coming. The level sill, which is setting the overflow for all the earthworks, will overflow over that level sill, and it's accurately set to be 100 millimeters higher than the bottom of the catchment swale. So this swale will catch water back to the dam, and then it'll hold 100 mils of water, soak into the soft swale mound up until that point where it goes over that level sill, which is 100 mil higher than the bottom of the swale. So that little feature makes this swale catch one way, back flood the other way, soak in and discharge. That's the piece de resistance on the whole thing. Actually, that's the thing that makes it all work. That's one of the tricks of level, is just knowing how to understand those little, very fine leveling points. So that makes this part of the earthworks multifunction.
All the resource materials.
And that makes a lot of difference between just having a dam and having a dam that also rehydrates the landscape as well as capturing some of the water in the landscape. The dam is an impoundment. The swale is a water harvesting system, a water soaking system which rehydrates the landscape, and it incorporates a level sill that discharges the water when there's an oversupply in the landscape. So totally multifunctional, harmonious little bit of reconstructive earth surgery.
1, 2, 3.
We had a few challenges there, and as we went through the job, even this stump's given us a bit of a challenge right now out there, but I think it's going to look beautiful actually. I think it's going to look a lovely little job. Wasn't that impressed to start with, but now it's come out really well, and as usual it's got a little bit more complicated and a little bit more interesting as we've gone along. So I'm pleased. I know the client's pleased and the students are pleased. I think the earth mover's pleased, he's learnt something interesting, and so it's all turned out good. Yeah. Principle of water: take the longest path over the most distance, over the most time, taken as long as possible, rubbing up against as many things as you can. The most passive friction is the most fertile. That's the principle of water. Using that in design, we can rehydrate landscapes, bring them back into production, bring them back into fertility, bring it back into stability. We can do it on a micro scale to a macro scale. It doesn't make any difference. We just have to do it, and we have to get on with it now. We can do it. Let's do it.